And welcome everybody to the Daily Space Weather. Today we're talking about a coronal mass ejection watch which is currently in effect. Sunspot analysis of Sunspot 2794 and 2795. Cosmological scale filament, our mission, and more. I'm your host Dan, aka smAsho. Thanks for tuning in, folks. First we're looking at two sunspot groups, both roughly Earth directed right now. Earth-facing quiet effect is in effect, and so the likelihood of large solar flares is lower. The likelihood of coronal mass ejections is still there. No sunspots in the northern hemisphere, and that's just 24 hours of solar activity. The radio flux is still at 88. There's a 1-year graph of the 10.7 centimeter radio flux, the radio output of the outer solar corona. Here is the sunspot number progression and the radio flux progression, and you can see how proportional those are. Here's a view in 94 angstroms, and we'll zoom in a little bit on the southern hemisphere, the site of most of solar activity, indeed throughout cycle 25 so far. And we're just about 13 months in to the current solar cycle. Great view there in 94 angstroms. And we've got some fantastic helioviewer movies. If you haven't checked it out, you can see Comet Erasmus up here, as well as Mercury down here. And I just wanted to show you real quick what it looks like when a cosmic ray strike happens on the LASCO C3. You see all these streaks here? That's not a meteor shower. That is cosmic rays striking the aperture. And this is similar to what you would see if cosmic rays struck your brain. It's like a phosphine, but in the electronics. Anyway, here's Comet Erasmus, and you can see a secondary effect there of that cosmic ray flux moment. It's not an alien spacecraft or anything like that. It's a reflection of its own aperture view. And you can actually see Mercury pop up. It's like a reflection of the lower half of its view, obscuring the view of Comet Erasmus. Let's go out to Lagrange point 5 at stereo A and explain why we have a coronal mass ejection watch in effect. And it's because we've got sunspots facing the Earth, and we've got a whole lot of plasma filamentary material in between the Earth and Sun. For your new viewers, the Earth will be out in this direction when viewing from Lagrange point 5. You can also see Venus there in the upper left, and a bunch of plasma on the opposite side of the Sun, the non-Earth facing portion. And we regularly see coronal mass ejections on both sides of the Sun. So again, don't be surprised to see a coronal mass ejection. Here's a full disk view of the last 24 hours. A great view there in 304 angstroms. And we've really got filaments. We've really got filaments all around this area here. And there's even some down here. So lots of filaments. And if a coronal mass ejection does occur, we'll be letting you know pretty promptly. And let's get to more data here. We'll show you the rest of our helioviewer movies at the end of the video, as we customarily do. If you haven't seen the Smash Lights segments, check out youtube.com/smashomash/playlists. We've got a bunch of playlists in there, such as smashomash.org presents the sun. Check out our own websites, and we're all over social media. There are the links to all of that at smashomash.com. Also check out our stores and our forum. Lots of interesting merch and material there. Thanks to our new subscribers over on YouTube. Please take a moment to press like and subscribe over on YouTube if you haven't done so, as we are in the process of growing massively. Thanks again to our new subscribers. Leave us a comment, press like and subscribe, share on your social media, get involved, click our links, perhaps pick up some merch, become a patron. And if you don't follow us on Twitter, you may not see brilliant memes like this about scientific consensus versus actual science. And yeah, I know it's silly, and that's kind of the point of the meme. Twitter.com/smAsho. If you're wondering what's going on in the solar system, here's where stuff is now. There's where things will be in a week on the 4th of January. 4 days into the 2021, the year of accountability. Here's a star chart from in-the-sky.org, as I'm always interested in what's going on above my head. And the moon's just about to set. If you're up before dawn, you may see Venus rise, thanks to our subscribers, followers, whatever you call them, over on Twitch, twitch.tv/smAsho. It's a fantastic streaming platform, twitch.tv/smAsho. Today we're going to talk cosmology for a quick moment. First, we're going to talk about coronal holes. Now, I talked yesterday briefly about coronal holes, and coronal holes give us important insight into solar activity, as they give us insight into where the solar magnetic fields are. And if you see that coronal hole right there, that's an interesting coronal hole to say the least, as it spent nearly 2 years on the solar disk. And I created this video last night, which features about 1 year of activity, as that thing went through about 50 plus Carrington rotations. And you can read all about coronal holes at solon.info. There's a section there that lists them. And keep in mind, they get renamed if they rotate all the way around the sun. And this particular one caused several geomagnetic storms on Earth. We'll release that in a video at a later time, specifically about coronal holes. I just wanted to give our YouTube viewers a quick preview. By the way, the Parker Solar Probe is sending data, if you were wondering. You can head to just type in Parker Solar Probe, you'll find the Johns Hopkins website. And if you click on Science Gateway, it'll show you, click on Data Availability, and that'll show you all the available data. Just click the instrument you'd like. The Whisper is the coronagraph on the Parker. So for example, on day 99, there are the images of the solar corona from the Parker Solar Probe. Thanks to Robert, who left comments about it. It's the fastest object ever built by mankind. So let's talk about our mission. And you can read about it yourself at smashomash.com/forum/mission. It's to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the relationship between space weather and Earth effects, hence these videos, to connect and consult with media organizations like YouTube and BitChute and our social media to multiply our reach, to demonstrate cutting-edge proof-of-concept solutions to problems like growing tomatoes indoors, which we're doing once again this winter, to publish scientific papers in a multidisciplinary manner, including but not limited to sciences like spectroscopy, chemistry, astrophysics, health, wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc. Many of them are being rewritten as we speak, folks. Also to assist mankind by advancing the study of predictive phenomena, not nonsense, to optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is, and to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion, as being ossified in your beliefs is not doing science. The rabbit hole of science regularly features us looking at nature, trying to figure out how it does what it's doing, dropping down a massive rabbit hole and realizing that we haven't received any answers to the questions that we were seeking, instead ending up with more questions and often answers to questions we weren't even considering. That's just the way science works. Deal with it like we do here at the Smash News Network. Next, I'd like to thank our patrons, the true source of funding for the content. Consider becoming a patron, if you don't mind. Patreon.com/smashomash. Please join at the $3 per month or higher tier, as we're discontinuing the $1 and $2 per month tiers. So thanks again to our patrons. And by the end of the month, by New Year's Day, the $1 and $2 tiers will be discontinued. We'll still have 6 tiers available at patreon.com/smashamash. And by the way, even if you're not willing to contribute financially, there are still public posts regularly put up there. So maybe consider following us on Patreon, as there's exclusive content even for those who do not contribute. Next, we're not going to roll dice today or look at transients at the Neil Gorell Swift Bat X-ray Observatory. That stands for Burst Alert Telescope. We're going to talk about a 50 million light-year long filament. Now, this is Able 3391, and in that area there, you could fit 1,000 Milky Way galaxies. And that filament there is what we're talking about. This is a composite image here from the E. Rosita radioscope. And you can find this article here on SciTech Daily. An unfathomably large intergalactic gas filament. So yeah, I've theorized about tens of millions of light-year in length filaments, and indeed there are some, most likely being ejected from the active galactic nuclei, coming out of the poloidal fields of those galaxies as they blast out a beam of protons, primarily consisting of hydrogen nuclei. And let's just say if you were inside those filaments, you would have a very high cosmic ray flux indeed. So these are galaxy clusters, folks, and that is about the scale of 1,000 Milky Way galaxy diameters. The Milky Way galaxy is like 50,000 light years in diameter. That's 50 million light years long. Have a read, if you like, at SciTech Daily. And it also links to the paper right there. And that's today's cosmology segment. Let's get back to data in the local space weather environment. Now, we just saw an uptick here in the solar wind as I did show prep. And it's come back down right away. Looks like maybe a little bit of coronal mass ejecta striking the magnetosphere. Just a temporary blip right there. A little increase, and I noticed it on the Magnetosphere movie as well. We'll show you that coming up next. Current conditions are solar wind speed still elevated here at 525 kilometers per second. Solar wind density around 7 protons per cubic centimeter. And the KP index has been pegged at 2 over the past 12 hours. So here's the magnetosphere movie, and you'll see right at the end, you'll see a little uptick in the magnetohydrodynamic pressure measured in nanopascals. So you see very low pressure there, especially in the bow shock, higher pressure in the magnetotail region. The sun would be off to your left on this. And here you'll see a little uptick, and then it should drop right back down again, right there. And that's that little uptick we just showed you in this real-time solar wind. Next, looking at ground magnetic perturbations. Since we're living through a magnetic excursion, a geomagnetic excursion, and we've got 2 north poles, one over Canada and one over Siberia, we view this data daily, as it is not viewable in the archive. We see pulses coming out of the Indian Ocean and the Pacific once again. I'll let it play through a second time, as there is a lot to take in there. Also, pulses going across the Atlantic Ocean. These are measurements of changes in the Earth's B field. So the B field is the field that goes through a magnet. And when you see delta B in science data, that means change in. I wanted to see if it kicked up any auroras. So I brought up the 30-minute auroral forecast here. You can link to this if you like at the Space Weather Enthusiast dashboard. They all have a series of links at the bottom of the page. And we do see a minor increase there in the aurorae. Places like southern Greenland and Norway would have experienced that. And let's continue on. Some more data here. The proton flux has remained flatlined. We cover it daily now as the likelihood of coronal mass ejections has increased. GOES X-ray flux is pretty flatlined here. No major solar flares, just some minor B-class flares. And the GOES magnetometer is quite spiky here. And as we forecasted yesterday, the Earth is now in the North Pole-oriented current sheet. We'll show you that in the next frame. And here you see the polarity of the heliospheric current sheet. North Pole shown in green, and you can see the Earth is solidly in a North Pole oriented current sheet. Keep in mind the data is 1 hour and 36 minutes old, and the magnetic environment can change with zero warning. Here's a line of sight coronal hole plot, and you can see significant coronal holes here associated with both polar fields. And we're expecting an increased coronal hole wind stream, an uptick in the solar wind here in the next 12 to 36 hours. And it's from this coronal hole here, the South Pole oriented one that's moved out of Earth-facing longitudes. We see some mixing going on up here too. The magnetometers aren't sure whether it's North or South Pole oriented. And here's just another view of the same thing. This one also shows you the solar poloidal fields, the fields at the poles, the poloidal fields, and the solar magnetogram. Last but not least, here's a magnetogram of the sun's atmosphere, the corona. A turbulent environment indeed. Next we'll talk electrons, and we see some minor charging hazards here over Mexico and the Central Pacific. There's the 1-year chart of electron flux. You can view that yourself at solon.info. Here's the forecast, and NOAA's forecasting a small uptick here in the next couple of days. I'm forecasting a downtick in the next couple of days as a result of the incoming coronal hole wind stream. And you've got to refute NOAA when it looks like it's going to be incorrect. Here's the 3-day chart of the electron flux, and our patrons would know that we tinkered with warning levels yesterday, shown as this dotted red line. And this one's showing you density. It's equivalent to 1,000 pulse flux units. Here's a visualization of the air column, showing you the total electron content forecast. This will give you an idea of where GPS errors would be located. And once again, we see some anomalies over North America and Antarctica. I'll let it play through a second time here. And you can see some unexpectedly high levels of electron flux there over the North American continent, as well as the northern part of Antarctica. And here's just a diagram in miles showing you the Van Allen belts to help give our viewers a better visualization of where those electrons are located. And the next frame is even better. It shows you in kilometers where the F layer is, and that's the F ionosphere layer. This is the D layer, this is the E layer. And the F layer is where the GOES 16 endeavors to make its measurements. This one also shows you penetration of electromagnetic radiation into the atmosphere, all the way down to the troposphere where the visible and infrared light makes it. The troposphere is where all of your weather occurs. Here's just the ionosphere layer, the F layer, that is. And we see some anomalies here in the southern hemisphere once again. Areas like the southern tip of South America and the South Pacific. This data courtesy of Australian Government Bureau Meteorology. And I'll bring up the latest image here. That is from wait for it, 6:15 Universal Time. No, 10 o'clock Universal Time. There we go. We do see rapid charge up and charge downs of the F layer today. Next, looking at volcanoes. I'm interested in what's erupting. Are you? We've got some updates, including on Ruppahue. Sakurajima is exploding, producing a 5,000-foot ash plume. Suwanosejima. Unknown size volcanic ash cloud. Please don't attempt to hang glide over the caldera. Bromo, now on the list. Located in East Java, Indonesia, it's producing a 9,000-foot ash plume. Ruppahue has decreased its activity here as the temperature of the crater lake has dropped. That's located on the North Island of New Zealand. So looks like a downtick there. The lake is not as hot. Popocatépetl exploding, 19,000-foot ash plume over that Mexican volcano, and Sabancaya is exploding as well. 26,000-foot ash plume is an indication that it's not a good idea to pole vault the caldera. Next, we're on windy.com, looking at pressure cells. There's the current state of affairs, and before I get back to that, let me just check the life of the stream here. And we are looking just fine. So you can see the U.S. is dominated by a high pressure zone centered over the Nebraska-Iowa border. North Pacific has a massive low pressure, as well as a low pressure there over the English Channel, the eastern portion of it. And we'll just advance this into tomorrow. This is the GFS forecast, folks. There's where we expect things to be at noon my time. And if you're wondering where we're located, Smash staff and I are located right about there in Lehigh Valley, Pennsylvania. And if you want to see the Euro forecast, there's the Euro forecast for tomorrow at noon. GFS, Euro, GFS, and let's move on. 2 earthquakes. We did see a 6.7 magnitude quake. We didn't clickbait about it. And a bunch of deep quakes happened also, such as this 4.3 in Afghanistan. It's over 200 kilometers depth. And this 5.1 at Chile, over 100 kilometers depth. So a small uptick there, and really we're still seeing a drought of earthquakes. Let's see what's going on in Hawaii. There's a quake there, not on the Big Island, in between the Big Island and Kauai? Oh, Maui. Between the Big Island and Maui. So here's the largest quake of the past 24. It's a 6.7 off the coast of Chile. No tsunami watches, warnings, or advisories were generated from that quake. Anyway, that's the location of that. So you'll see a bunch of aftershocks there, no real surprise. A deep quake strikes the Philippines. And another deep quake strikes the Philippines. Also, we saw 5.2 at Croatia. And only about a dozen minutes later, we saw a 5.2 at the Owen fracture zone. Not a particularly common place to see one there, southeast of Saudi Arabia. And basically, the earthquake drought continues. A drought of 6, 7, 8, and 9 magnitude quakes. Let's look at the jet streams. That's what's going on nullschool.net's jet streams. We're looking at the 250 hectopascal winds. And we've got the jet stream blowing the wrong way across the southwestern Pacific and the Indian Ocean. As the jet stream normally blows west to east, not east to west. Here are the jet streams of the Western world. The Western world's jet streams are all over the place, just like they were yesterday. We cover it daily here on the Daily Space Weather, a standard feature of the Smash News Network, least busted name in news. Next, we're looking at the GOES lightning mapper, and we don't see a lot here around America. Some in Southern California, though. Some significant lightning out there, as well as in the South Atlantic. Here's lightningmaps.org. It's what I use when I hear thunder. You can even forecast thunder using lightningmaps.org. And hey, Oceanside, there's thunder rolling in. If you're viewing from Marine Corps Base Camp Pendleton, thanks for your service. There's thunder rolling in. Convince your friends that you're Odin and your foes that you're Thor by forecasting lightning at lightningmaps.org. Next, looking at the U.S. Doppler radar map here, and we're going to show you a forecast. There's some heavy snow forecasted here for places like Iowa. We'll get to it. There's the current state of affairs in terms of U.S. Doppler radar map, and we've got some heavy snow in central Pennsylvania, as well as snow in New Mexico, which isn't all that common, and some wintry mix, perhaps freezing rain or sleet happening there in the Oklahoma Panhandle. So here's the forecast through Wednesday, December 30th. And you can see 10 inches forecasted there for southern Iowa, northwestern Missouri. And we don't want to go much farther ahead than that, as forecasting more than 5 days out is pretty silly, and it's why we don't do it. If you don't understand the forecast, if you don't understand the physics, you're not qualified to forecast. Here's what's going on in the cloud layer. We've still got significant low clouds here over the Atlantic Ocean. And we use the NASA GOES Interactive Weather Satellite shortwave radiation map. I believe it's 3.2 nanometers, 3.9 nanometers. And here's the water vapor. There's the cloud layer once again. And there's the water vapor. And that should give you a better idea of what's going to happen next. If you're looking at the Doppler radar and wondering, just zoom in on your location using this water vapor map. It'll give you insight. And stay tuned for bonus features, as we've got to show you the solar intensity gram, the colorized magnetogram, and a couple more HelioViewer movies. So here's the colorized magnetogram. This is the latest image in ultra high res. Close-up of Sunspot 2794 on the right, and 2795 on the left. And 2795 has actually started to degrade a little bit. And is that active region rising a sunspot? Well, it doesn't look like it. And here's the degradation of these sunspots. There's 2794, which has remained quite stable. And 2795 is looking like it's breaking down here, as those umbrae aren't even solid dark umbrae. We see a lot of light bridges going across those umbrae, an indication it's probably degrading. It's also facing the Earth-facing zone here, which decreases the likelihood of solar flares, but does not decrease the likelihood of coronal mass ejections. And indeed, that active rising region is not a sunspot at the moment. So last but not least, here is a close-up of the southern hemisphere in 171 angstroms. Great view there of the main activity occurring on the local yellow dwarf. And we'll also show you the magnetogram. And the magnetic fields have remained pretty stable here. You can see a little bit of degradation of the leading umbra associated with Sunspot 2795 there. It's about time to close this thing out. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. Don't drink no matter how much the government drives you to drink, and if you do drink, don't drive. I've been your host, Dan, aka smAsho Mash. Welcome to the Neo-Renaissance. Please share the videos on your social media. And since it'll never be now again, may that solar wind be at your back.